We've reached the end of this year's SDRA, and I have the honor to conclude. Well, actually, it's not my honor. Here we have the real contributor, Lawrence. Thank you, Lawrence, for your email. And I turned your email into the conclusion because Lawrence sent me a number of very, very interesting comments, and I think this is worth, well, actually, this is the conclusion. It's a lot of text. I just pasted his email, cut it a little into pieces and pasted it into slides. So Lawrence thought about, so this is actually your talk, isn't it? You want to come to the stage?
No, you're doing fine.
Okay. So Lawrence was thinking about where are we going in the next 10 years? And he thought that, well, we're seeing a lot of commercial products in HF, VHF, UHF, and microwave. And one interesting point was, is there a point in time where digital signal processing becomes cheaper than analog processing in terms of a higher dynamic range and speed and so on. And Lawrence sees two different developments. One is an analog chipset based for FM and digital modes, and a DSP-based chipset for SSB and high-performance transmissions. And his hypothesis is that Lawrence doesn't see analog HF radios there anymore in 10 years. So that's an interesting point. We will most certainly see better SDR, wider bandwidth, higher dynamic range, and let me try to summarize that. Diversity antennas, distributed transmitters, distributed receivers. However, this will need stable oscillators and more digital voice modems, something that would probably be there. And FPGA design could become more accessible to developers if it is used as a graphical design approach and kind of a new radio companion for FPGAs. Well, in fact, I have a promise by Matthias Jung to give us a lengthy talk on FPGA design next year. So we're already negotiating what we'll have next year, and FPGA design will be a big topic next year. And also chip design, processor design, because he's currently giving a lecture at his university about chip design, and he designed a 8-bit CPU together with his students, and it's an 8-bit CPU, it's not very fast, but nevertheless, he did it, and it's not very expensive because you can do that for about 100 euros. So this is probably something that might be here in the next years for us, also in the amateur radio community, that you can design your own processing unit. So this is going to be there. Xilinx, Vivado with a graphical environment, something like this is absolutely possible to be here in the next years. Artificial intelligence, big topic. So something like ChatGPT, but networks, neural networks that can be trained to be a recognizer or a transducer and produce something else out of it. Yes, absolutely. We have seen a talk, I remember a talk from that Swiss university a couple of years ago, where somebody was presenting an interface for GNU Radio to connect to AI engines. It was kind of a standard protocol, a standard interface. So we are seeing this already by now to a certain degree. Maybe not yet the big picture, but there are the basic bricks already in existence. and somebody needs to put the thing together and produce a really good, nice picture and nice system out of it. So yeah, this is something that we are definitely going to see, at least, well, maybe even closer to today than in 10 years. Yeah, pan-adapter display with the intelligence has detected many signals present and already decoded them. A little into that direction, we're going to that direction with OpenWebRx, but you still have to detect the signal manually and say, I'd like to see that one. And then in some protocols, OpenWebRx can detect and say, okay, this is this and this and that. But of course, not yet trained in a trained manner as you could have it with artificial intelligence. Yeah. AI has already set the signal level attenuator, ATC filter, high, low bandwidth. Yeah, of course. This is something that I would expect also. And I would also expect that to be around earlier than in 10 years, maybe already in 2 or 3 years. Latest, probably. The use of standards, big topic. So there are so many people developing so many proprietary things. So we should talk about proprietary developments and how to standardize things, how to standardize interfaces, and make developments more exchangeable. Absolutely, for sure. This is also something we need to talk about. And I remember a talk, oh, that's a long time ago. Who was it? Felix? I need to think about the speaker. Open source and amateur radio, or open source and SDR. Yeah. So why do we have open source, and what is the benefit of having open source? Because there are interfaces everybody can use, and of course everything needs to be well documented. Without good documentation, open source will not work. If people keep their developments private, open source will not work. So documentation and interchangeability is the absolute precondition of any kind of open source development. So yes, this is something that needs to be thought about in the community. And well, at least what I see from Josh Mormon's talk, at least in the GNU radio community, this smaller, well, it's not a small community anyway, but in this smaller community within the radio research field, they are definitely doing that. So, standards for the control of RF front-end antenna selection, pre-selection, filtering, attenuator selection, recording, a standard for recording, a standard for later processing, a standard for controlling the settings, like the, what's the module called? Hamlib? What is the Linux library? That kind of standards could be very, very interesting and very beneficial. Yeah, a standard for recording audio samples, and a standard for later replay, a standard for, well, comparable ideas for a TX signal path, a standard for IQ down converters, baseband receivers. And this actually, I like these ideas very much, because when you remember, when we started in the morning and Christian Enzfellner was here, he was thinking about a kernel, an open source kernel. So we're actually coming back to exactly these ideas. So these are the ideas that need to go into the project, which is brought forward by Christian Enzfellner. Standards-based interface to GUI, to anything kind of which is related to user interfacing. I mean, if you have a look at the transceivers which you put into your rack, they're all more or less the same. They have a knob in the middle, They have a button on the left or on the right, and they have some little switches in between, and they have a digital interface on top, maybe with a pan adapter below or on top. So they're all more or less the same. The HMI is already going to that way. But we have to go a little further and take also our discipline into that direction. GUI supports plugins to control accessories like RF front-end rotator, power amplifier, and ATU. Yeah, for sure. I mean, all those devices, I mean, it's so fantastic that everything we produce, everything we in our projects produce, in the meantime, has an Ethernet interface, which is great. But I think we can still take this idea further. And the summary of Lawrence, it says, some of this is beyond SDRA, and is more softer controlled radio, but we could be advocates for the relevant open standards. Just imagine that there is one VSWR bridge in the radio. Its samples could be used for PA protection, ATU tuning, operated display, and the software to do these things could all discover each other rather than needing to be configured. Yeah, plug and play. Yeah, just have them in the same network and say, yeah, how many ATUs are out there? How many PAs are out there? Can I connect to them? Can I play a signal stream to a modulator that is up there on the mast? Or something that's somewhere in the internet? Maybe I'll look up in a database. I have a signal generator. I can produce the waveform, and I'll just forward the waveform to somewhere and have it transmitted there. Or I have a receiver somewhere, or I have multiple receivers somewhere in the internet, somewhere around, and I just connect to the IQ streams. And I retrieve the IQ streams from those devices, and I combine them. And I can listen to things which I could never ever receive on my side. And distributed receiving and transmitting. Well, I'm sitting at home with a nice little HMI with a knob in the center and a pan adapter and a little button, on-off button on the left or on the right, you know. All those things that support a good user interface. Yeah, some of this can be done today, but not all of it. And well, there is still a lot to be done. And I hope all those ideas will finally make it into the concepts as put forward by Christian Enzfellner. So I'm at the end here, and Lawrence, thank you really very much for these ideas, because this is exactly, these are the things that needed to be said at this point. And they look very far into the future, but not only far, but also to the near future, because this is something that can be addressed until next year. So we have 1 year to go, 1 year to work on things. And I would like to thank you for coming. I would like to thank everybody for contributing. The fantastic speakers we had. We've been talking about the community. The community consists of a lot of people, a lot of people contributing their time, their enthusiasm. I would like to thank my video team, because they are really absolutely fantastic. Please give them a warm applause. And also our sponsor, Professor Rode, and everyone who has made possible that we can have this event here. So hope to see you again next year. And enjoy the sights here in Friedrichshafen. Don't get wet. I think it's going to be rainy afterwards. And thanks for coming.